lecture in a Solidity. And again, remember, the goal here is to just have that information that you need to take the test. So don't think you need to be a programmer. We just need to get some ideas across so you know what to expect when you get to those specific portions of the test that you may or may not get, right? So syntax, just like English has grammar, just like French has its own grammar, just like Chinese has its own grammar, in computer science, you get programming languages, and the grammar for a programming language is called syntax. That's all it is. Syntax is grammar. Every term, every word, every phrase, every symbol has a specific meaning. And those terms that you're going to use, and you're going to see, are things like variables, expressions, functions, modules. You'll see constructors. You'll see all those things that go into this. And essentially, that's all it is. Syntax is grammar for whatever programming language you want. It has its own dictionary. It has its own processes. A lot of this stuff is really standardized now, given the era that we live in. The one thing to remember that you really do want to know is that we have to have compatibility between different systems. So Solidity uses a JavaScript standard called ECMA script, right? And it's a syntax that makes it familiar for existing web developers and other ones that you can actually then turn your web developer into a Solidity programmer relatively easily. The big thing that they'll have to remember is that it's static typing and a certain kind of return type called a varidic, right? So EMCA JavaScript is just that. It's just meant to be interoperability. So just like we were talking about with React and Angular and Vue, if you're using one, you're going to be fairly comfortable with the other one. And again, the idea is know one, master one, get used to working with everybody else. Now, the other thing that you'll see me note here is you've heard me say Camel Notation or Camel Case, right? It depends on what era you were raised in. When I was raised in programming, it was Camel Notation. It also can be known as Camel Case. And essentially, it's really stylized. It's just a practice of writing phrases without spaces or punctuation. Now, the first word, like camel, is always lowercase. The second word is uppercase. And that's why it's camel. Got a little hump in the middle. So I know, computer programmers, I'm sorry, but that's really it. It's just the separation of words with that single capitalized letter, and the first word starting usually with lowercase, but in some cases it will start with an uppercase. It depends on your programmer and what era they were raised in. Right? Now, you may or may not see questions that will ask you to differentiate between something, right, using camel case. So you should really just understand that that camel case is generally the second word and every other one that has capitalized. The other thing to make sure of is that if you need anything to do with Solidity, Solidity Docs is absolutely the #1 best resource for you to use. Solidity will walk you through exactly how to do this, the structure of a contract, how to compile it, how to test it, how to do all the things that you would ever want to do. And right now they're on version 8.15, VO 8.15. So they update this all the time. And that's where you get that idea of the word Pragma in there, that first line of the code, which is Pragma, which tells you what version your contract is good to operate with, because that will help when working with a contract. So our tie into our 1411, 1400 protocol stack, very specific operators like balance of, address token holder, external review, turns an unsigned integer, 256 bits long. So when we want to break that out, we break that out into something called pseudocode, or we break it out into something a little bit more English-like. So if you see that function balance of address, blah, 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 that really just means that we have a function, right? Name balance of, that goes to the address of the token holder. So I want to check how much money that token holder has to make sure they can buy my super awesome NFT, and returns an unsigned integer of 256 bits in length. It will tell me how many tokens, whether that's Cube, whether that's Wave, whether that's Ethereum, whether that is Bitcoin, depending on which protocol you're using. 1155, right? You can have different kinds of things. You can get the balance of all their wallets out of the blockchain, right? You don't have to go pester their wallet at all, and they'll tell you how much money they've got and whether they can really truly afford that NFT that you want to buy. So things like balance of are really super handy when you're building all this stuff out, because that compatibility with the protocols and our functions and our ERCs, and do we have enough money to actually pay for that, all go hand in hand. break out these, and now these also, if you want to do something, right, break these out into pseudocode. Authorize operator function. So that authorize the operator at this wallet can take actions on my NFT. Revoke the operator. That operator that I authorized earlier, I want to revoke them now because they did hinky things. They sold my stuff I didn't want them to. And then is operator, right? Is that person actually the operator of this NFT? Are they actually the owner of this NFT? If yes, it's going to return Boolean, 0 or 1, yes or no. So you can basically tell. Simple. Once you get used to it, right? Once you get used to it, you just have to really get used to breaking these things out. And it can be really kind of interesting. Now, other syntax. This Pragma Solidity that tells the program, right, that I'm good from version 0.7 to version 0.9, right? And that this is where you need to be. This is what version of the contract I'm good to working with, right? And computer programming, that directive or Pragma is a language contract that specifies how a compiler should process its input. I don't have any other better way of saying it, right? Pragma, this is the input. This is the input I can take. I can work within this range. Please only work with me in this range, right? It's like checking to see if I'm sending the right kind of data to the right kind of interface, right? You don't want to send a bunch of number data to an interface that's expecting a text box back, right? So directives are not part of grammar of a programming language. They are going to vary compiler to compiler. C, C#, C++, Python may or may not even use Pragma. It just all depends, right? So remember that in Solidity, though, we do. We use Pragma. It is the first line. We say Pragma Solidity and then the versions that it's good for. So greater than or equal to 0.7 or less than 0.9. That's it. That's all it works. And it's interesting they didn't use the equal to 0.9. Just anything that's below version 9 is good to go here. And then reserved keywords. Every program has keywords that you can't use as a variable name or as a function name or something else. You don't need to know all these languages, all these words. You just need to know that reserved keywords are just things you can't use to name your variables, your anything else in there. Right? And that's it. It's actually really straightforward. Once you have someone explain it to you, the idea of having syntax is just like grammar. It's just how you build things together. You have special words, you have special conditions, you have a special language called camel case that you can use. It all starts making sense. It all starts driving together. So watch this as many times as you need to make sure that you really do understand camel notation. You really do want to be able to pick that out of a file. You really want to understand about that because you really might get questions on the test about that. And again, this could be surprising, may not be surprising. You may not get those questions, but you are going to be darn ready for them if you get them, right? Because you watched this and you're good to go. If you want to dive deeper and you want to become a Solidity programmer, Solidity documents are obviously and honestly your best friend, along with Stack Exchange and a bunch of other items out there that are beyond the scope of this lecture. But just know that syntax is like grammar. It's like how you spell words in English or French or Chinese or anything else, Mandarin. And just know that you use camel notation and be able to pick things out of a test question if you need to. And that's it for this section. That is it for Solidity. Again, just a really quick run through of the programming language. You don't need to go into depth on this one. But I think if you know just these things that we've taught you in this section, you're going to be good to go. I will see you in the next lecture.